For thousands of years, beavers were among the most important architects of Scotland's landscape, though most people never realized it. Long before roads, cities, and flood barriers existed, these animals quietly shaped entire river systems. Their dams slowed rushing water, created wetlands, and transformed narrow streams into thriving ecosystems filled with fish, birds, insects, and plants. The rivers moved at a natural pace, spreading water across the land rather than sending it racing downstream. But as human settlements expanded, beavers became increasingly valuable for all the wrong reasons. Their thick fur was highly prized, their meat was considered a delicacy in some regions, and a substance called castoreum, produced from scent glands, became valuable throughout Europe for use in medicine and perfumes. As demand grew, hunting intensified. Year after year, beaver numbers declined, until eventually the species disappeared entirely from Scotland.
By the early 2000s, a growing number of scientists had begun asking an intriguing question. What if Scotland's rivers weren't naturally damaged at all? What if the disappearance of beavers centuries earlier had fundamentally changed how water moved through the landscape? To find out, conservation groups proposed something that had never been attempted before in modern British history. They wanted to bring beavers back. The idea sparked years of debate. Some supported it enthusiastically, believing it could restore lost ecosystems. Others feared it would create new problems for farmers, landowners, and fisheries. After extensive discussions, the Scottish government finally approved a carefully controlled experiment. In 2009, 11 beavers, captured in Norway, arrived in Scotland's Knapdale Forest. But this wasn't simply a matter of releasing animals and hoping for the best. The project became one of the most closely monitored wildlife experiments ever conducted in Britain. Scientists installed water gauges, pressure sensors, cameras, and monitoring stations throughout the region. They measured river flow, water quality, vegetation growth, insect populations, fish numbers, and countless other environmental indicators. At first, the newly released beavers seemed unremarkable. They explored their surroundings, established territories, and began behaving exactly as beavers always have. Then, the construction started. Rangers surveying the area noticed the first dams appearing across narrow streams. Made entirely from sticks, branches, mud, and vegetation, these structures looked simple compared to the massive flood control systems humans typically build. Yet their impact quickly became impossible to ignore. As the beavers continued working night after night, streams that once rushed through the landscape began slowing down. Water collected behind the dams, creating ponds where none had existed before. Small wetlands started reappearing in areas that had been dry for decades. Each year, more dams appeared. Some were small barriers, spanning only a few meters. Others stretched much farther, reshaping entire sections of waterways. The transformation spread beyond the water itself. Plants that depended on wet conditions began returning. Reeds, sedges, and aquatic vegetation expanded into newly flooded areas. Insects followed. Frogs appeared in growing numbers. Birds started using habitats that hadn't existed previously. Even larger animals were drawn to the changing environment. The landscape.
Despite the growing excitement surrounding the project, one major concern threatened to undermine everything. Scotland's Atlantic salmon populations are economically, culturally, and environmentally important. These fish migrate upstream to spawn, often traveling great distances through river systems. Critics of the Beaver Project worried that dams could create barriers preventing salmon from reaching breeding grounds. If true, the reintroduction might cause serious ecological harm, despite its other benefits. The concerns seemed reasonable. After all, a dam made of branches and mud certainly appeared capable of blocking fish movement. Scientists therefore devoted significant effort to studying the issue. They monitored salmon populations, tracked migration routes, and examined how fish interacted with the growing network of beaver dams. Initially, many expected to find evidence supporting the concerns. Instead, the data revealed something surprising. Most beaver dams were built on smaller tributaries rather than major migration routes. Unlike concrete structures, beaver dams were porous. Water flowed through and around them rather than creating solid barriers. During periods of heavy rainfall, many dams became even easier for fish to navigate.
But the biggest surprise involved juvenile salmon. The ponds created by beaver activity provided ideal habitat for young fish. These calmer waters offered protection from predators and reduced energy demands compared to fast-flowing streams. Researchers discovered larger and healthier juvenile salmon populations behind many dams. Areas that previously supported few fish suddenly became productive habitats. The very structures some feared would damage salmon populations were often helping them thrive.
As years passed, the amount of data collected from Knapdale grew enormous. Scientists analyzed thousands of measurements covering storms, river flows, groundwater levels, and ecological changes. Then something extraordinary happened. The numbers stopped matching existing flood models. Researchers had expected beaver dams to influence local conditions, but the scale of their impact exceeded many predictions. Across the landscape, over 100 dams had formed, creating an interconnected network of water storage systems. During heavy rainfall, these structures slowed floodwaters and spread water across floodplains instead of allowing it to surge rapidly downstream river. Studies revealed flood peaks could be reduced by as much as 60% in some locations. Millions of liters of water were being stored naturally within wetlands created by the beavers. Rather than rushing through river channels in a destructive wave, rainfall was absorbed, delayed, and gradually released over time. This process reduced flooding while simultaneously increasing water availability during dry periods. Water quality improved as sediment settled behind dams instead of being carried downstream. Groundwater levels rose. Previously dry channels began flowing again. Some researchers admitted that their computer models struggled to reproduce the real-world results they were observing. The beavers had effectively created a self-maintaining flood management system.
By the time the official trial reached its conclusion, the evidence had become difficult to ignore. The beavers were not only surviving, but transforming ecosystems in ways that produced measurable environmental benefits. In 2016, the Scottish government announced a historic decision. The beavers would stay. What began as a cautious experiment evolved into a major shift in conservation policy. Yet the official Knapdale population was only part of the story. Elsewhere in Scotland, additional beaver populations had become established, and their numbers were growing rapidly. Surveys revealed expanding territories and increasing family groups throughout several regions. Over time, Scotland's beaver population climbed from the original 11 animals to more than 2,000 individuals. Legal protections were introduced. Perhaps the most important lesson from this story extends far beyond beavers themselves. For generations, people approached flood management with a simple philosophy: control nature. Build bigger walls, dig deeper channels, straighten rivers, force water to behave according to human plans. Yet the results were often expensive, temporary, and sometimes counterproductive. The beavers offered a completely different perspective. Instead of fighting natural processes, they worked with them. Their dams slowed water rather than blocking it entirely. Their wetlands stored excess rainfall rather than forcing it downstream. Their engineering increased complexity instead of reducing it. The success of the Knapdale project challenged long-standing assumptions about how landscapes function. It suggested that some environmental problems may be easier to solve by restoring natural systems than by replacing them with artificial ones. This does not mean beavers are a perfect solution everywhere. Conflicts with agriculture still occur, and careful management remains necessary. But the broader message